Okay, let's jump in here. This will be a very informative video also. Let's data stack and you come to your own conclusions. Let's look at the core sample again. We talked about this crack a long time ago. This could have been from them removing it. I doubt it. It doesn't look chipped. I think this is an existing crack. I did a real world test on some tile that the guy had to take up. I did it myself. I brought out a little hammer and I started breaking tile out here to see if it would migrate over. And there was a lot of tile that had been broken up. So I got the sample, new tile over here, new tile here, new tile here. Just kept doing it to see if I can get it to the forces from the impact of the driver to drive over. Because it's just a tile, it would stay within that tile. It didn't pass over the grout and make its way over. I then started chiseling sideways to see if I could get it to travel over. Now I get the tile to pop, and the pop would fracture it, but I couldn't get it to just create a fracture like this, where it's two directions. See, there's two directions going on here, this direction and that direction. So this could be just a stress crack from going down or up. Looking at this, I can't zoom any closer than this. But if you were to flex a tile, you would get exposed edges here. Either way, you're coming with the same difference of the cracks looking pretty similar. And I can't zoom in any better, so I can't tell if it's a compressive crack or a crack that was that was bonded, which we don't see that, and that somehow the deck flexed up. I consider that craziness, right? The deck isn't going to flex up. It could, because it's by a column, and it could be a negative load over there that helps hold this side up, and this side is actually dipping down. Gives the impression of what I just said, described. Here's the core the exploratory hole. Core sample's next. This is exploratory to expose down to the structural deck per the requirements of the engineer Morbido. And there's this document, and this appears to be a dried, rigid, not as flexible, let's put it that way. Waterproofing, and I state not as flexible because this appears to be a crack presenting itself through and not presenting as a crack. I can't see the tile over here to see if it's cracked, but remember they had a sand leveling bed that actually is a bond breaker for cracks that they don't travel through and mirror through to the tile. That bond breaker, if it was bonded to the surface, it'd have been one-to-one cracks. They would just crack the tile. Anyone who's done an overlay of concrete over an existing control joint, a construction joint or a control joint, when it moves, you'll get it happening right there, right through. If it cracks below, it will just put the pressure right above. This box, this curbing being, let's do this. Good enough for me. Let me make it very thin here. And tie on right there. And tie on right there. So this curbing has a little dip in it. See the extra concrete right below the line? And oh yeah, I can do this with this one, I think. Yeah. So right below the line there's some extra curbing, concrete. And as you taper off and get over here, we can see that this reveal is probably the same with the leveling bed below it, or the entire curbing is one, and this is just a parge and coloring on top of it. And maybe I could bring that down more, just a touch more. And I lost it over there. Let's take a look. Yep. And, well, yes, across the tile top. How about that? And then we see that it's a slight bit of an illusion of the depth. Here's where I care about let me get rid of that. I care about this depth being equal. It can be actually flexed like that, as long as it's equal all the way down. And it's meeting there. And that's about right. I have to extrapolate from there. From this one, I don't have to extrapolate pretty much, using Yeah, this pretty much looking good there. But this shows a deflection in the deck. This crack, this material hardened up over these years, and the crack below mirrored through. There is also evidence of that. Evidence of that in the core sample. When we go to the core sample located there, this is in front of there, we see that we have a destroyed core sample. You couldn't bring this over for testing because it's already failed. It's fully separated, dissected, if you will, and the rebar is not engaged with the concrete. I think this rebar, you could probably turn it and not put it back. If you turn this around, that little knot probably fits in there. So they probably had it apart, just placed it back together, kind of, you know, haphazardly, if you will, because this should go there, and maybe another piece of rebar should go across this direction, but it's kind of low for that. I think it would be up here on top of the chair, up here, and this should be down here, is what I speculate. So the, I don't know what this toothed out section is. And remember, that concrete looks more like grout than anything. Whoa. So over here by the car, this is the part of the video that I really wanted to get to, but I had to give you the little background data. This is the other core sample where the vehicles are parked. Here's the planter box, and here is where the Miami Herald says that went down first inside this structure. But I already showed the planter box is in place in the video, and also the ledge is here. And I show it, you know, I like playing Columbo moves. So right now I'm getting busted on all my Columbo stuff lately. People are just like nailing me. So my man and forensic guy in Florida, on the phone with him, telling him what I was up to, he nails what I'm about to say before I say it with my Columbo move. I'm like, oh my gosh, I didn't post a video. And I was like, I said, I gotta improve my skill set on that. And then Catwoman's been banging me with some of her analysis. I'm like, oh, Catwoman's killing me here. I got to get tougher. I mean, and then just now, someone else just, I talked, I'll bring the video up, but I put the mouse right where I was talking about, and I indicated off of this too. And my man must have paid attention, because it was no less than, I don't know, 12 minutes after the video posted that he commented saying, oh, I see the crack over there by the wall, by the planter box. And I'm like, wow, amazing. So I'm very proud of you guys. So look, this is the planter box, I believe. The crack I'm going to show you looks like this. What I told my man, I gave him a couple of hours to since I posted the video, or an hour or so, to try to reply back. I told him, run with it. What do you see? What do you see? Well, now here's his answer for him. Look where it's coming off of, a column. It's coming off a column, and that's just about where the planter box saves also. But it saves all the way over to the door. We see, remember, I don't mention stuff just to be mentioning it. I just give Columbo hints. There's that black piece of roofing I talk about. And I say it kind of nonchalantly in a previous video about, oh, I guess that's that. But I really want you to understand that it must be standing on something, right? And so it's standing where she states it shouldn't be. I give you this guy here. I got to make sure I show you a photograph of that. I got to put that in my brain. Show you a photograph of that. A nice image I have of the palm tree. So we have this thing standing up, the slab standing up, and then we have the palm tree standing up. The slab was the slab, question mark, what landed on this outer section and drove this down equally. But there's another give me that I put in another video, and no one seemed to run with it. So I'm going to give it to you again. There's a crack right about here where the cars are. And the other crack is over here where I keep saying it, fronting over here like this. That crack, right? That crack there. Now, run with this crack. Back to here. You see they're parallel each other? They're parallel, and this is also where we have the building coming down in its capacity, and roughly that direction, and there's some building materials across here. Here's the planter box. Correction, yeah. Planter box is here, the one we see with the shrubbery still in it, and so the materials are like this, something like that. And there's another large impact of the stairwell that we see across here like this. I'm going to shift that over a bit. because we see I'm shifted over because we see that it's about like that. There's you're right about there is where you have your palm tree coming out of. So palm tree is coming out of here. Okay, then we have that there. This crack is here, but this crack is existing, which I showed you from the port shot, looking down. This crack is existing. This shows that this crack, it didn't, and I talked about the tiles, so I don't give everything, I'd give everything for a reason. So the tiles, the deck flexed is what I'm driving at to create this flack, this crack. We see that after the structure collapsed, this is in place. So this is telling you that this did not flex. So what does that mean? That means from out here somewhere, the deck took a moment, had a moment presenting as downwards. If you remember in the report of one of Morbito's report, he said he saw cracking in the tile. Remember I went out of my way to find that lady and try to find, we saw the image of the lady standing there at the pool, and we went looking for cracks, and we couldn't find them. Lo and behold, I found the crack, that's over here and presented to you in the video now. And I have more images and data, but I'm, frankly, I like to give it out after somebody's already stepped in it. And then I'm like, no, you're missing it. You got it wrong. Like, for example, I'm not done with that wall over there with the stone. I might show you the photograph. I already showed it to a couple of people where that stone is just the stone on the outside of the wall. And it's not standing straight up plumb as Josh thought it was. They don't know how to collaborate. So, and frankly, I intimidate them, so they don't want to get hold of me and say, "Hey, can we go over this together?" I know how to collaborate. I run it past a few people, some of my things ahead of time. Some of them, to run it past. Like, for example, I ran the wall past my man in Florida. That part of it, I ran it. He busted me on something I was going to do. I had the video. I was ready to share it to him in a private link. And then out of nowhere, I said, nope. I just debunked it myself. So I said, no, it's trash. Most of the video is really good content, but that one section there just trashes the video. So, no, but it took me talking to him out loud with him to realize where my defect was. And so look, the dip is here. So there's our anchor point. Our anchor point is this column, right? The column there, and there's another column here. So is the dip between here and here with the car loading? It could be, and it also could be a much larger dip from this area to this one. Let me rotate a little bit. But now I need to show that the forces are, this crack, I've found out these cracks like to go in you can do like I'm doing here, this little butterfly thing, and you could mirror it and start extending it out and looking for where's the stress. Where's the stress on this? And if I follow this and chase it, well, I want it at this column. I'm in the deck though. I'm not out. I'm in the deck, but in this case, I'm around the critical shear zone. So I wanted to show you that most people misunderstand critical shear in the imagery. Let's see if I can do that one. I think I'd like to come back to this, but I'll probably let me force quit something here. And I want some personal stuff coming up in the background because people will get a little freaky on me, sending me messages with showing me the personal stuff. That just freaks me out. So mail I can quit. And this stretch is junk. I'll keep open. I don't care if you see that. All right. So so this is the deflection, and this is the part that stayed behind. So that was already a shear plane being created, and it's a weird shear plane because it's like this. I'm trying to double back down. It's like this. And here's the flower box up here. So it's this capacity, not this capacity. So let's put that as a flower box. Not this capacity, and I'll show it to you in the video again. It looks like that, which is a very unique failure of its own. All right, remember this doesn't have stirrups in it. This deck is 9 inches thick, and I consider that to be just looking at a giant beam section across this whole deck. That's how my brain visualizes it, my supercomputer. And I just see it as a beam, and I go, oh, okay, so we're just having bottom steel in our beam, and bottom steel failure in a beam connected at columns, which this is the defect in testing. When you see load testing, which I got tons of videos coming up for you on that, they don't secure it at the columns. They just put it on rollers a lot. It allows the ends to have a reaction. They put it on deflective plates that will deflect and allow for that. That's not how the column behaves. I'm actually going to state, and I'm already sent it off to a couple of schools already to do the testing, that that this is not a shear failure. When you put rebar at the bottom and you load it at the top, and you load it here, that it's actually not a shear failure. The column, the connection is here. Shear would be over here. We call this shear because that's the way everyone's decided it should be. I'm going to prove to you that it's actually a tension failure, a failure that it no longer can hold the connection in tension. Because at this failure, we get an explosive reaction, and this goes bursting off into the air, explosively, away from it. A shear would just leave this there, and this would go down. But there's always, as Newton says, an opposite and equal reaction. Opposite and equal. That's why one of my things I just waiting for somebody to finally bust me on. I gave it to you a long time ago in a video, and I think I might have deleted it. That if Newton's third law is correct, that everything's equal and opposite, well, gravity means nothing. It cancels itself out. If it's pulling down at 10 pascals, whatever you want to say, whatever measurement you choose, well, it's being pulled up by the same amount. So it's a wash. It's a wash. Gravity you have is linear, doing one thing, pulling down. When you put an object in the air and you tell me it's gravity pulling it down, well, it's canceled out also. Now you're going to tell me the stem of the apple tree. Well, the stem of the apple tree is resisting it. That's what I agreed to, actually. It's equilibrium, that the stem of the apple tree is holding the apple. And when the apple's mature enough and heavy enough, the stem fails, rips away from its connection, and falls. The stem is failing, not some magical force pulling the apple down. It's not that way, and all of a sudden the apple has no longer kept its equilibrium in size, because remember, gravity says that its relationship to its size, that the amount of pulling it is. That's why it's so negatable, it's so nothing, so small, so whatever. Well, in that case, the apple got bigger, and by chance, gravity reacted on it more to pull the apple off. Or the apple was mature, it's just a drain on the tree, not needed anymore. And so the tree, through brilliance of nature and creator, has it so that apple increases in size, too much mass, it's now just no good. Let it go. So the stem rips from the tree, no harm, no foul to the tree, and bye-bye, apple with the stem. It takes the umbilical cord with it. Isn't that amazing? The umbilical cord, you see it now for my medical people out there? All right, so let me go to, get rid of this. Oh, I said I would show, wait a minute. Let me cancel this and go backwards in my brain. Because I started canceling, my brain realized I wanted to show you something. Oh, I got it now. Yeah, I got to go backwards in my brain to do that, and I can do that sometimes. Not all the time, but most of the time. So, save. Yeah. And then let's pull up the next window under punch shearing. And so, let's do that. And so this image here is one of my better ones to talk to you about it. So this says it's a punch shear failure. Okay. So this, everyone says it's a punch shear failure. In reality, it's a brittle failure. The critical shear area is in place. And the steel was this was so over reinforced in here that it was made very strong and stiff. And the span had some flexural ability to it. So as it cycled, it kept cycling into this stiff, rigid area. And instead of being, because rigidity, you can make something too rigid with concrete and have something flexural next to it, and you see what happens. You're ramping up. Imagine a ramp up in the stress diagram. It's flexing here, and it's ramping up, but it's coming to a brick wall, if you will, a soft, plastic, more plastic, numbers. Say this is a 90, and over here is 100 when it hits right here. And so it's not a handoff, a smooth handoff from 90 to 90 over here, and just a nice strain relief, if you will. Incidentally, I totally dislike this type of slab detail. I think beams should be put in them, period. And if you gotta, make it just period, beams everywhere, not this drop panel or above integral panel detail into the slab. Integral panel meaning the critical shear area is just increased with steel. It becomes too rigid. Look at all the steel there. Now, you're saying Champlain Towers failed because they didn't have enough steel. Well, if that's the case, this shouldn't have failed. This looks like it's in a triangle array, meaning well squared up. And yet, this is the pad we're looking at down here, so you guys know. Look at the pad. See it? And this was up here. And this was up here. And I got to slow down my brain for you. And there it was out to there. The critical shear steel went out to here. But you can see where it broke cleanly off. And over here also. And yet it had tons of steel. All that steel. I do not see the steel this direction, though, in this imagery. I see that this pad is down, but I don't see the steel in the other opposing direction going across the critical shear area. So that allowed for it to, as it was loading laterally, that it didn't have anything to transfer laterally into this this very brittle, stiff area. No rebar. So it laterally, having your arm out trying to reach over, it can't do it. And this is where it's sort of like, I visualize it like this for me. You visualize it once you do the load testing and see the failure. So let's do, okay, so we're looking at the end of the rebar here. I guess I should do a circle. I got one of those, right? Yeah. Let's do two of those. And let's put this at the bottom of the imaginary beam. I don't know if I have to wrap it up for you or not. There's the bottom of the beam. And I guess I will. I'll do this. And this time we'll go ahead and make that larger so you can see it. All right, so you're loading here. And let's say the forces make it like this. And that's a weird arrow, but you know what? We're going to delete that. We'll make a better arrow. And they're loading like that. Of course, they're loading down here. They pick it up. But this one, let's just say by chance, it transfers because of the ratio, the thickness of the deck. It transfers here. Well, it didn't get picked up by the one to the right. So a fracture develops between the two. So if you had the steel a little closer, now the steel, it won't deflect and it gets picked up by the steel. So you load it here and vice versa. This steel picks up that one on the 45 and also this one. So now we got the right spacing. Bottom steel only. Bottom steel only. We don't have anything connecting it. No stirrups or anything else. And just wanted you to see how I visualize it. Now to help you visualize it better for you engineers out there, let's move this over here. Now do you see my point? At one point, you've got too much concrete between the two of these. You've got too much concrete between your two supports where it won't be able to make it over to the other piece of steel. Where it won't be able to make it over to the other piece of steel, the loads. And so you get your break between the two of them. In this case, I think we're looking at right here. I don't see that steel going over there besides these two ears out here. The two out there that are deflected down, obviously. And it doesn't make it over. Also, we have the brittle fracture where it's so rigid because of all the extra steel that the deflection in the deck makes it over to this rigid part, and there's no handoff. It's just a quick run up to a wall, and like a hammock being, okay, it's like a screen in your house where it's at the edges. You can push on the screen a little bit. If you keep pushing, you're going to puncture the screen, or you're going to rip it from the edges. So, depending on where you load it, you'll rip from the screen, or you'll puncture through if you get near the middle. I was actually going to do a screen test on you. Get it? Screen test. And let's get rid of this. Save that for the heck of it. Posterity. So we see over here that this is where the car, I showed that crack already. This is where the car sample, right here is where the sample is. We see the structure fell completely cleanly down where the cars are, just broke free. We have a history of a crack up here, which I'm going to now pull up here in this video. But I want to give a shout out to, and now we do the shout out to Cheeseburglar. I think it's Cheeseburglar. Hold on. Where is your Cheeseburglar? Did you see the cracked tiles right above where you were pointing? That's right. To the picture looking down from the porch. And I told him, I said, you nailed it. Just home runned it. I put the mouse. See where to put the mouse? I'm going to play the video now. This video's titled right here. Champlain Towers, Palm Tree, and Planet Box Revealed. Remember, I was going to always keep talking about this. And that's why I was always willing to challenge anybody that wanted to go live with me. Any engineers wanted to go live with me that are doing this content. I had so much hidden. I still got some more hidden. But I'm running out of my hidden on the inside, outside the structure. Inside, I have another path for you that reveals. But just staying outside, the cracks were so critical, as you recall, I mentioned. And as we see, there's the crack, and that's over going towards the column. There's your vehicles on the other side of this planter box. This planter box stays. This is why it stayed during the collapse, because it was already, what? Failed. A crack equals failure. You're not going to cross the crack. Now, it means failure in the tensile strength, the connection. Clearly, it's a break. You can regain that to some degree. You can still capture it on this side if you had rebar going across. To some degree. At some point, you flex too much, and now you're, or cycling is terrible. At some point, you're flexing too much. But to get this to crack openly like that, you have to have, in this way, we know 100%, this is not theory. This is, well, it's theory, but it's 100% theory. This is exacting, already there, existing. We know that per the images. It's there. It didn't fall. So the other side of it had to flex. The other side is where the cars are. This is our plane, just about our plane where it does fail. Now let's play the video for about 1 minute. Where the concrete rolls over the other direction. Hold on, I guess I got a better volume. Hold on. Watch out, put my mouse there. Cheeseburger nailed it. Planet box is up here. This is where I have another video coming out. I think this one's right here. Before that one, where this shows. Well, I'm debunking Miami Herald again in that video. But the big release is this palm tree. And there's the black pad background. Straight. Tree. And also take note of. A door. Where'd you go, little guy? I'm gonna back this up. I'll use that one if I can. Yep, this works. The survey. I'm going to back it up. So hold there's on. The 90. There we go. Bevel direction that I showed you better. Okay, so let me back it up. So I point there. Cheeseburglar sees just where I'm pointing and runs with it. Hold on. Let me go back again. There it is, mouse again. Column system that comes over the. See, I talk about the column. I'm giving it to you. Got to put it together. Put it together. You know I love my slow, easy hints, not just 100% here it is, but this one, I'm cleaning it up for you. There it is. There's your planter box. There's that wall step, column system. See, I say wall, column. You know I don't stumble on purpose, on accident. Okay, here we go. Box. There it is. There's your planter box. There's that wall step, column system that comes over. The shear plane comes this way. But way out here is where we get that bevel direction down. And that's where I talk about it, right there. Way out here, and I put the mouse right over it. Cheeseburglar nails it. I point at the line of the crack right there. That's the one point, and then there's the other path of it there. Markings, I don't know. But look at the planter box. There it is. There's your planter box. There's that wall step, column system that comes over. The shear plane comes this way. But way out here is where we. Way out here, and right by there, right at the crack. Get that bevel direction down. So let's move this out of the way a bit. And there's the bevel. There's your planter box. There's that bevel direction that I showed you better. And another another image. You come out with about 3 tiles. So about 3 tiles, somewhere about here. See, I'm right on the crack, right on it. And Cheeseburger saw it and called it out, so Cheeseburger gets the amen on that one. Where they roll over, where the concrete rolls over the other direction. It's a weird rollover. The box is up here. This is where, because it's fractured on a plane in a 45 the other direction. They're dipping that way, and the tension was at the top, opening it up. I have another video coming out. I think this. But the crack tells you that it was, which I didn't just go to the other video for the sport of it. Just think again, the handoff, the critical shear area, how this is handing off and showing itself with that crack across diagonally from that position from the column. Diagonally, meaning not parallel, like a 45 off from that column. So visualize the stresses that would create that, a 45. And I showed you the parallelness. And then I said I'd always get back to this one with you. I showed you the parallelness, pointing backwards with the V shape. That's the end of this video. Hope you catching on. All right, love you guys. Bye. So, but I want you to think biasly. Cars area. I wish they had a video. I wish that they spent all the money on these cameras, and nobody seems to come up with a video. I want to take this time to, before I terminate, the NTSB is looking into, and I was going to do a video on it, into the Pittsburgh Bridge. And the newscaster said, the news reporter from Pittsburgh said, hey, to the NTSB, look, there was a bus on the bridge. They have cameras. Let us look at the cameras. Oh, no, NTSB, oh, no, we only released what we released to the public. And he was like, well, it's got cameras. Let us see the camera view, you know. Oh, we'll determine the possible cause, probable cause and all that. And he was like, all right, well, we want to, you know, have access to the bus cameras. Well, they're a member. They signed up to be a member of our NTSB report. So we control the release of the data is what they're saying. And the guy was quite pissed about it. I'm going to do a video on it about, you know, saying, you know, really? The video, we got to wait, what, 2 years? I think he called her out on that, or maybe I'm making that part up. I don't know. Maybe, I don't know if I'm biasly making that up, but I think 2 years we're going to be waiting for it, or maybe somebody said that in the comments. I don't recall. But we're going to be waiting for it, or was it my man down in Florida when I told him about it? So, to be waiting for the video, and maybe they won't release the damn video, a clip of the video knowing NTSB. They already released their B-roll. But their B-roll could have been part of, which I was going to do a video on for you guys. Their B-roll could have been part of just showing the damn bus video. They already had it. And I don't know why you guys think so proudly of NIST or NTSB. They're just so nasty. They're a governmental official governmental mouthpiece. And they just want to control the narrative. That's all. It's that same lady again with the Kobe Bryant thing that just started off from being a civic association president or partner there, and so, to all of a sudden being head dog in an NTSB investigation. That was just craziness. That's the person that's dealing in Pittsburgh right now. I'm like, you know what? When you got such corruption like this, you can't get real information, and I give you the real information that I can. It's up to you to interpret it. I'll do some interpretation for you, but I'm not going to tell you. I'll tell you in a code what I think really happened, but I'm not going to. I'm going to show it to you, and I'm leaving it open for you to debunk me is what I'm driving at. I want to tell you this, though, before I end. This means something. See that right there? That means something. What is it? All right, let's see who busts me on that before I get a chance to tell anybody. Bust me on it, though. I'll welcome it. I'll give you a hint. If you go, new people searching, look up plastering detail, exterior plastering, molding. Look up in it for Florida, things like that. Look that up. And then once you understand what it is, you tell me what happened.